Assalamualaikum and greetings to the respected lecturers of Integrated Design Project 2, Semester 1, Session 2021-2022. I, Nurul Syazwani binti Samri, will present the minor department, which is the drainage design, sewerage design, road design, and reinforced concrete design. So these are my members that were in charge in the minor department. So let's jump into the first minor department, which is drainage design. So for drainage design, it is separated into three parts, which is number 1, drainage system design, number 2, culvert design, and number 3, detention pond design. So the number 1 is drainage system design. So drainage system design is necessary to assure that the stormwater capacity is deep enough to move through the building by gravity. So for this part, the objective is to determine the drainage system's effectiveness. Number 2, to identify the most appropriate size of drain. Number 3, to ensure that the project stormwater is correctly managed. And number 4, to design the open drain U-channel and detention pond and culvert. So, the location of the proposed project area in Mukim, Pulau Johor has been divided into 16 sub-catchments, where each sub-catchment is connected to form a larger catchment at the lowest proposed level. Next, to determine the value of the final result, we must calculate the time of concentration TC. So, the time of concentration is for urban catchment or PEF surface that can be calculated by referring to the guidelines in MASMA, where as shown in the table. So there is a few assumptions has been made to calculate the time of concentration. Number 1 is flow velocity is equal to 1 meter per second. Number 2 is the return period is for 5 and 100 years. We also need to determine the runoff coefficient. So the runoff coefficient for urban catchments, by referring to the table shown, is also the guidelines from MASMA. So, for the average recurrence interval of 10 years and 100 years were used based on the location of the sub-catchment. So, the summary of the result are shown in the table. Next is the rational method. So, the peak flow of the sub-catchment region is determined using a rational method in this project. So, also, there are a few assumptions that have been made, including the fact that rainfall intensity is uniform across a time period equal to the time of concentration. So, the rational method formula is as expressed in the figure. So, the table shows the peak flow for each sub-catchment using the rational method equation before. So, the values of the constants are taken from the rain gauge location, which is Pusat Kemajuan, Kempekan Nanas. The table shows the comparison between peak flow, Q peak, and the design flow capacity, Q cap. So the design flow capacity, Q cap, were calculated by using Manning's equation. So the peak flow and flow capacity were compared. If the design flow capacity is bigger than the peak flow, it can be concluded that the design section can be used. So as the result, the Q capacity is more than Q peak, so all design from each sub-catchment is okay. Let's move to part 2, which is culvert design. So in this chapter, culvert design has been proposed into 3 sections in the zone. As shown in the figure, there is 3 culvert design. So the length of culvert in the range of 12 meter to 18 meter. There is also another assumptions have been made, where the inlet invert level is equal to 23 meter, the outlet invert level is equal to 22 meter, and the tail water level, TW, is equal to 24. So next is the culvert design sample calculation. So by taking culvert number 3 as the sample calculation, first we will calculate the maximum headwater height, HW max. Next we calculate the estimated required waterway flow area by assuming the inlet control, and we also check the outlet control. So from the calculation, we can conclude that the HW inlet control is less or smaller than HWO outlet control. So therefore, the outlet control governs. So this is the summary of the culvert design. The drawing showing the outlet control with the headwater height of 1.18 meter and the headwater at proposed level of 46 meter, and the outlet velocity equal to 1.92 meter per second. Okay, next we move to chapter 3, which is detention pond design. So there is several steps that we must follow to obtain the final results. So the first one is setting the design storm criteria, where the design storm for 5, 50 and 100 years of average recurrence interval, or known as return period. Number 2 is compute the pond inflow hydrograph. So we must calculate the time concentration for pre and post development. Also determine the maximum time concentration. So for this design, we obtain the result of pre-development equal to 30.47 minutes, and also for post-development equal to 10.16 minutes. Steps number 3 is determine the point of flow. So there is several constants that must take into consideration, which is the derived parameter of lambda, k, theta, and also n value that were taken from the location of pusat camp Pekananas. And from that, we can computed and tabulated the pre-development discharge and also the post-development discharge. Next, step number 4 is the preliminary estimate of pond volume. So the preliminary estimate between the required volume and VS storm duration using rational hydrograph method. So step number 5, we develop a pond grading plan. So this is the drawing from the AutoCAD of the detention pond system. So based on AutoCAD, the total area for detention pond is 14892 meter cube. Step number 6, we compute the stage storage relationship. So we can conclude that the provided volume is more than the required detention pond volume. So the design for detention pond is adequate. Next, let's move to the second minor department, which is sewerage design. So this project was divided into 3 zones, where each zone will have a sewer treatment plan that were proposed in this design project. The population equivalent calculation, we will obtain the value of PE. So from that, we can estimate the class of STP. There is few things need to be considered in designing sewerage system, such as type of manhole and type of pipe. There is 4 type of manhole that has been outlined. Number 1 is the shallow manhole, number 2 normal manhole, number 3 deep manhole, and number 4 drop manhole. There is also different types of pipes, such as vitrified clay pipe, reinforced concrete pipe, cast iron, asbestos cement, fabricated steel with sulfate resistant cement lining, and also plastic PVC. But in this design, we choose VCP because it is only known to damage by the hydrofluoric acid and the very concentrated waste. By taking zone 1 as a sample calculation, we will calculate the flow rate in the pipe, the design of pipe, the level and depth of the manhole to obtain the final answer, which indicates either the manhole within the requirements or not. For the conclusion for the sewerage design, this is the drawing for the manhole and also the manhole cover. The third one is road and traffic design. This is the overview of the design. First of all, to identify the traffic road data, we must know the number 1, population, number 2, the census station, number 3, the terrain. The calculation of road gradient has been calculated, and it shows that all road gradient is less than 3%. So it shows that the terrain at our zone is a flat terrain. Next features is average daily traffic. So average daily traffic is defined as the average 24-hour traffic volume at a given area over a period of time less than a year. Next component is trip generation. So trip generation is the first phase of the traditional 4-step transportation forecasting method, which also includes trip distribution, mode selection, and route assignment, which extensively used to forecast the travel demand. The next component is intersection design. So first, we must know the location of junction. So there is 3 warrant check that must be fulfilled. Also, we must design by using the ATJ 13/87 guidelines. And in the design, we use a 3-phase cycle calculations. Let's move to the last minor department, which is reinforcement concrete design. So this is the scope of work. Number 1, draw structural design. Number 2, make a design assumption and qualification. Number 3, analyze the structure using software Orient 18. And number 4, design the staircase manually. This is the structural outline for pile footing foundation, underground floor, ground floor, first floor, roof, and also the 3D model of the buildings. So next one is the design analysis of beam, column, and slab using the Orient 18. We can generate either the proposed dimensions of slab, dimension of columns, dimension of beam that we propose is suitable enough to carry the load from the structural building. It also generate the detailing for the beam. Foundation, either pad or pile footing, can also design using the Orient 18. Design analysis of staircase and certain members of column, beam, and slab has been done manually. It is to compare the analysis and result by using manually calculation and Orient 18. So from the compared analysis of manual computation and analysis through Orion shows that Orion is applicable in analyzing a design. Moreover, Orion software also simplifies the process of building analysis, since the software provides to calculate the analysis required for members of the structure. That's all from me. Thank you.